Hi friends, welcome to our YouTube channel Naraj Academy. The main aim of this lecture is to discuss about the mathematics previous year questions of PSUs in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notification comes on mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Please do watch all our videos in the YouTube itself so that our channel can reach to more number of students. I hope you will do it. So let's get started. So now we are going to solve the fifth one question. See the question here. Let S denote the surface of the cylinder, which is x square plus y square is equal to 4, and the range of the z is from -2 to 2. Then what is the surface integral of the z minus x square minus y square into ds? We need to figure out. So basically in this question they are given a surface of some cylinder they have given, where x square plus y square is equal to 4 and the range of x is from -2 to 2. So on the surface we have to do what is the surface integral of this function, which is z minus x square minus y square. On the surface we need to figure out what is the integration, double integration, because surface is going to have the 2 dimensions. So because of that we are going to go for the double integral. So out of these 4 options, option D minus 64 pi is the correct solution of this question. So let's solve this numerical. So in this question basically we have to find what is the surface integral of the z minus x square minus y square into ds. The surface here, the question they are given the surface as, the surface is x square plus y square is equal to 4 and the range of z from -2 to 2. So basically it is a cylinder. It is a cylinder of radius 2, because 4 we can write, which is 2 square. So therefore we are going to get a cylinder in this fashion. So therefore this is a cylinder we are going to get in this manner, and the cylinder here we have to do this is a radius of 2 and the value of z is equal to -2 to +2. Then here we have to find on the surface, we have to find what is the value of this integral we need to figure out. Means on the surface we have to do the surface integral across the surface we have to do for this function. This function we have to do the surface integral we need to figure out. So basically here the 2 coordinates, so we in the terms of the Cartesian coordinate system x, y, z. So I want to convert this into cylindrical coordinate system, and then I can do the analysis in a very faster manner. So therefore I am going to convert this Cartesian coordinate system to a cylindrical coordinate system. So Cartesian coordinate system values are x, y, z, and for cylindrical coordinate system values are phi, z and rho, phi and z. The relation between them is x is equal to rho cos y is equal to rho sin phi, and ds is equal to, because you can see clearly for this cylinder, as we are not going to change in d rho, in the rho axis we are going to change only in the phi axis and the dz axis. So therefore rho into d phi into dz. So this is the amount of change in the a phi axis, and this is the change in the terms of the az axis. So you have to go for the dot product of these two things. We are going to get finally rho d phi into dz. This is a ds. And a circle, the cylinder is going to have a radius of 2, so rho is equal to 2. So now we know each and everything, just you have to substitute in this equation, which is z is equal to z. There is no thing, so therefore z is equal to z. Both are same. So x is equal to rho cos phi and y is equal to rho sin phi, and ds is equal to rho d phi dz. So substitute each and everything. So this is minus rho square cos square phi minus rho square sin square phi. So if I take minus as common, you are going to get in this fashion, and if you take again rho square as a common, we are going to get like this one. So therefore cos square plus sin square is nothing but 1. So finally we are going to get here like this. Finally z minus rho square into rho d phi dz. So finally we are going to get in this term, but there are 2 variables. So if you want to cover the whole surface, you have to go from phi 0 to 2 pi and z from -2 to 2, but rho is equal to 2. So substitution everything, rho is equal to 2, then here 2 you are going to get, and 2 square is 4, z minus 4 into 2 d phi dz, and phi is going to vary from 0 to 2 pi and z is equal to -2 to +2. Then only we can cover the whole cylinder we are going to get cover. So now as 2 is a constant value, I am going to take it outside the integration, double integration. So you can see clearly z is equal to -2 to +2 and phi is equal to 0 to 2 pi, because z is independent of phi and phi is independent of z. So we can go for the separable way of integration. So therefore 2 from z is to -2 to +2, z minus 4 into dz, from phi is equal to 0 to 2 pi d phi. So we have to do the integration of this two things in order to get the solution. So this is the equation we have got. So now we have to do the integration of this one to get the solution. So here integration of z minus 4 with respect to z, which is z square by 2 minus 4z, you have to substitute the upper limit and lower limit. And similar integration of d phi is again phi, you have to go for the 0 to 2 pi, substitution of limits. So 2 into, if you substitute the upper limit, we are going to get this term minus of, if you are going to lower limit, we are going to get this term into 2 pi minus 0. And if you do the simplification of these things, we are going to get 2 into minus 16 into 2 pi. So 2 into minus 16 into 2 pi is minus 64 pi. So therefore this is the correct solution of this question. So basically in this question we have done like this, converting from Cartesian to cylinder, and then we did the simplification in this manner. So therefore we have got the easy solution. But if you want to do in terms of x, because if you want to cover that cylinder, both the variables are varying, x and y are also going to get vary. But here only the phi and z only are going to vary, but rho is a constant. So we did the simplification a very somewhat easier. So if you want to do in terms of Cartesian, it will take a lot of time. So but this is a very easier way. So this is the correct solution of this question. So now we are going to solve the 52nd question. See the question here, the eigenvalue of this matrix. So they are given a certain matrix of cos alpha, sin alpha and cos alpha. So for this matrix we have to find what is the eigenvalues we need to figure out. So out of these four options, option D, cos alpha plus or minus sin alpha is the correct solution of this question. So let's solve this numerical. So in the question they are given a matrix here, which is cos alpha, sin alpha and cos alpha. So for this matrix we have to find what is the eigenvalues we need to figure out. So basically now we are going to solve this question by two methods. The standard procedure method is, which is, first we have to find what is the determinant of this matrix, which is a minus lambda is equal to 0. So if you do this calculation, we are going to get cos alpha minus lambda, sin alpha, cos alpha minus lambda, determinant is equal to 0. So if we have to find the determinant of this matrix is equal to 0, we need to figure out. We are going to get finally cos alpha minus lambda whole square minus sin square alpha is equal to 0. So if we expand this equation, finally we are going to get, in this manner we are going to get, but cos square alpha minus sin square alpha is cos 2 alpha. So therefore lambda square minus 2 lambda cos alpha plus cos 2 alpha is equal to 0. So this is in the format of x square plus bx plus c. So therefore a is equal to 1 and b is equal to minus 2 cos alpha and c is equal to cos 2 alpha. So these three terms we have got. A is equal to 1, b is equal to minus 2 cos alpha and c is equal to cos 2 alpha. So you have to find the roots is equal to minus b plus or minus under root over b square minus 4ac by 2a. So we have to substitute a, b and c in this equation. We are going to get finally in this format. If you substitute all the values of a, b, c in this equation, and if you do the simplification, we are going to get 2 cos alpha plus or minus under root over 4 into cos square alpha minus 4 into cos 2 alpha. So you can take 4 as a common, and if you take it outside, we are going to get 2. So 2 cos alpha plus or minus 2 into under root over cos square alpha minus cos 2 alpha by 2. But cos 2 alpha is equal to, but we already know that, so 2 is going to get cancelled. Finally we are going to get cos alpha plus or minus under root over cos square alpha minus cos 2 alpha. But cos 2 alpha is equal to 2 cos square alpha minus 1. So if you substitute in this equation and if you do the subtraction, and then finally we are going to get cos alpha plus or minus under root over minus cos square alpha plus 1. But minus cos square alpha plus 1 is equal to sin square alpha. So sin square alpha take on the root. So we are going to get root is equal to cos alpha plus or minus sin alpha. So these are the eigenvalues of this matrix. So this is a basic standard procedure. So now I am going to discuss the shortcut method to solve this question. So now we are going to solve this question by very shortcut method, or simply method 2. Here first we are going to find what is the trace of the matrix and also the determinant of this matrix. So trace of the matrix is equal to sum of eigenvalues is equal to, just you have to do the addition of the diagonal elements, which is cos alpha plus cos alpha is equal to 2 cos alpha. And similarly the determinant of this matrix is equal to the product of the eigenvalues. So if you do the, we are going to get, so if you do the determinant of this matrix, we are going to get cos square alpha minus sin square alpha. So therefore now we have to check from these options which is going to satisfy these two conditions. So you can see clearly only option D is going to satisfy all these conditions, which is the sum of eigenvalues. So one eigenvalue is here cos alpha plus sin alpha, and the another eigenvalue which is cos alpha minus sin alpha. So if you do the addition of these two terms, we are going to get finally 2 cos alpha. Yes, this is satisfied. And if you do the product of these two eigenvalues, which are cos alpha plus sin alpha into cos alpha minus sin alpha, so finally we are going to get, which is cos square alpha minus sin square alpha. Yes, both these conditions are satisfied. So therefore option D is the correct solution of this question. So now we are going to solve the 53rd question. See the question here. Consider the equation real part of 1 by z is equal to c, where z is a complex number and c is a non-zero constant, and the real part of z. So the area of bracket, it is going to represent the real part. The equation describes here. So basically in the question they are given the real part of 1 by z is equal to c. So therefore we have to find what is this function is going to represent finally. What is the nature of this function we need to figure out. So out of these four options, option C, circle, is the correct solution of this question. So let's solve this numerical. See in the question they are given that the real part of 1 by z is equal to constant, where c is called as a constant. So we have to know what is the nature of this graph we need to figure out. But z is equal to x plus iy. So you can substitute in place of z is equal to x plus iy. We are going to get the real part of 1 by x plus iy is equal to c. So I am going to do the rationalization with respect to, I am going to multiply by x minus iy by x minus iy. So I am going to get x minus iy by x square plus y square is equal to c. So I am going to take the real part and the imaginary part. So therefore I am going to get, which is x by x square plus y square minus I into y by x square plus y square is equal to c. But I want only the real part but not the imaginary. So therefore only I will take the real part, which is x by x square plus y square is equal to c. I can do the simplification. I can take this c to this side. I am going to get x square plus y square is equal to x by c. If I take this term to the LHS, we are going to get x square plus y square minus x by c is equal to 0. This is, it is going to look in a general format of a circle equation, which is x square plus y square plus 2gx plus 2fy is equal to 0. This is the general equation of any circle. Then the center will be minus g comma minus f, and the radius is equal to under root of d square plus f square minus c. So if you compare these two equations, this is the equation of a circle. So therefore we can say the correct solution of this question is, it is a circle. So now we are going to solve the 54th question. See the question here. The algebraic multiplicity of the matrix A. So in this question they are asking, there is a matrix A. For this we have to find what is the algebraic multiplicity we need to figure out. So basically multiplicity means how many number of times the eigenvalue of this equation is repeat, of this matrix is repeat. So the number of times the eigenvalue of this matrix, the repeating, that nature is called as the multiplicity of that matrix. Out of these four options, option C, 3 is the correct solution of this question. So let's solve this numerical. So this is a matrix in the question they are given. So for this matrix we have to find what is the multiplicity of, we need to figure out. Basically multiplicity means the number of times the eigenvalue is going to repeat, how many number of times it is going to repeat, that we are going to call it as a multiplicity. So first we have to find what is the eigenvalue, which is determinant of a minus lambda is equal to 0. So if you apply this one, we are going to get finally, this is the matrix we are going to get. So for this matrix we have to find what is the determinant we need to figure out. So after doing determinant, we are going to get minus lambda into 3 minus lambda plus 3 minus 1 into 0 plus lambda. So we have to solve this equation. Finally we are going to get in this format. So this is a cubic equation we have got, which is lambda cube minus 3 lambda square plus 3 lambda minus 1 is equal to 0. So for this we have to find what is the roots we need to figure out. So in order to find the roots, I am going to take all the coefficients 1, minus 3, 3 and minus 1. I am going to assume that lambda is equal to 1 as a root. So therefore if you substitute lambda is equal to 1 here, the first value should be always equal to 0. So 1 plus 0 is 1. 1 into 1 is plus 1, minus 3 plus 1 is minus 2, minus 2 into plus 1 is minus 2, 3 minus 2 is 1, 1 into 1 is again 1, minus 1 plus 1 is 0. So if this last part is equal to 0, then it indicates that x is equal to 1 is a root. So therefore lambda minus 1 into, I can write this is, as it is a cubic root, one root we have already know, the remaining will be order of 2. So therefore lambda square minus 2 lambda plus 1 is equal to 0. I am going to find what is the nature of the roots of this equation of quadratic. So therefore for 1 I can replace minus 1 into minus 1 is again plus 1. So minus 2 is equal to minus 1 plus minus 1. So like that we are going to do the simplification of this equation, which is lambda square minus lambda plus 1. So in these first two terms I am going to take the lambda as a common. So lambda into lambda minus 1, and the second two terms I am going to take minus 1 as a common. Then I am going to get lambda minus 1. So in these two terms again I am going to take lambda minus 1 as a common, then lambda minus 1 into lambda minus 1. So this is the lambda minus 1 and these are also two other roots. So finally we are going to get in this format is equal to 0. So this is equal to lambda minus 1 whole cube is equal to 0. So simply the eigenvalues of this matrix, which is 1 comma 1 comma 1. So therefore these are the eigenvalues. The eigenvalue is equal to 1. It is going to repeat 3 number of times. So therefore that is called as the multiplicity of the eigenvalue. So therefore 3 is called as the multiplicity of the eigenvalue, which is lambda is equal to 1. So 3 is the correct solution of this question. So now we are going to solve the 50th question. See the question here. The area bounded by the curves. The area bounded by the curves y is equal to x and y is equal to x. So these are the two curves which are the y square is equal to x and y is equal to x. So is given by, see what is the area is going to bounded by these two curves, which is y square is equal to x and y is equal to x. So these four options, option C 1 by 6 is the correct solution of this question. So let's solve this numerical. So in the question they are given the two equations which are the y square is equal to x and y is equal to x. So between this, what is the area bounded we need to figure out. See now I am going to draw the graph which is y square is equal to x. This is the black one and the red one is the y is equal to x. So you can see clearly these two are going to intersect. They are the 2 points. So we have to find what is this intersection point between these two curves. So if we want to find the intersection point between the two curves, then we have to do the simplification of these two curves, which is y square is equal to x. But y is equal to x, so in place of y I am going to replace y is equal to x. So I am going to get x square is equal to x. So I am going to take the x to the LHS. I am going to get finally x square minus x is equal to 0. So I can take the x as a common, then I am going to get x into x minus 1 is equal to 0. So if I equate to 0, we are going to get x is equal to 0 and x is equal to 1. If x is equal to 0, if I substitute in this equation, then I am going to get y is equal to 0. If x is equal to 1, if I substitute in this equation, then I am going to get y is equal to 1. So these are the two intersection points which are 0, 0 and 1, 1. So this is 0, 0 and this is 1, 1. So these are the two intersection points of these two curves. So now we have to find what is the area which is bounded between these two graphs. So we have to find what is this net area between these two curves we need to figure out. So if you want to know what is the net area, which is the formula is equal to modulus of the integration of x0 to x1 f1 minus f2 into integration of dx. So like this you have to go for this one. So therefore here we are doing the integration with respect to x variable. So x is changing from 0 to 1. So x is changing from 0 to 1. So now y1, the initial y1 is equal to under root over x minus, and this is x into dx we need to do. So therefore this is the net amount of area which is bounded between the two curves. Y square is equal to x and y is equal to x. So by using this basic formula, so I am going to do with respect to integration from x0 to x1. So from x is equal to 0 to x is equal to 1. So if you do the integration of under root over x, we are going to get 2 by 3 into x to the power of 3 by 2, and integration of x is x square by 2. And if you substitute the limits, x is equal to 0 to x is equal to 1. So upper limit minus lower limit, if you solve this one, finally you are going to get area is equal to 1 by 6. The basic integration of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. So by using this formula, we have done the integration, and if you substitute the upper limit minus lower limit, finally you are going to get the answer as 1 by 6 square units is the correct solution of this question. So now we are going to solve the 56th question. See the question here. If alpha and beta are the roots of the equation x square minus px plus q is equal to 0, then summation of alpha square, means we have to find what is the summation of square of roots. Then what is the net solution we need to figure out. So alpha and beta are the roots of this equation, then we have to find what is the sum of the square of the roots we need to figure out. So what is four options? Option C, p square minus 2q is the correct solution of this question. So let's solve this numerical. So in the question they are given that alpha and beta are the roots of this equation, which is x square minus px plus q is equal to 0. So alpha and beta are the roots of this equation, then we have to find what is the summation of squares of these roots we need to figure out, or simply we can say that alpha square plus beta square we need to figure out, which is sum of square of the roots we need to figure out. So basically first I have to find what is the summation of the roots and also the product of the roots. Summation of roots is equal to the basic formula, which is minus 1 all to the power of, here we are going to take only one term at a time, so therefore minus 1 all to the power of 1 into coefficient of here x to the power of n minus 1 by coefficient of x to the power of n. So here n is called as the highest power, here highest power is equal to 2, so n is equal to 2, so you can substitute here 2 and here also 2. So x to the power of 2 minus 1 is again x to the power of 1, and this is x square. The coefficient of x to the power of 1 is minus p, and the coefficient of x square is 1. So therefore minus 1 into minus p by 1, we are going to get p. Similarly, if you want to know what is the product of the roots, which is minus 1 all to the power of, you are going to take two terms at a time, means 2 terms means you have to go for the 2 into coefficient of n minus x to the power of n minus 2. So coefficient of x to the power of n minus 2 by coefficient of x to the power of n, where here n is equal to 2, so therefore 2 minus 2 is 0, and here 2. So we can say that the coefficient of x to the power of 0 is q, and here the coefficient of x square is 1. So you can substitute here minus 1 whole square is 1 into q by 1, you are going to get q. So therefore the summation of the roots is equal to p and the product of the roots is equal to q. So we have to find what is the alpha square plus beta square. So alpha square plus beta square I can write, which is alpha plus beta whole square minus 2 alpha beta. So alpha plus beta whole square minus 2 alpha beta is equal to alpha square plus beta square, but we know the value of alpha plus beta and also alpha into beta. So you can substitute these things, p square minus 2 into q. So simply we are going to get p square minus 2q is the correct solution of this question. So by knowing the what is the summation of the roots and the product of the roots, by substituting in this equation we got the value of the alpha square plus beta square is equal to p square minus 2q is the correct solution of this question. So now we are going to solve the 57th question. See the question here. A curve y is equal to f of x passes through the point 0, 5 by 2 and has a slope of x into e to the power of minus x square for the tangent at a point x, y on the curve. Then the equation of the curve is, so basically in the question they are given a slope of the curve at a particular point which is x into e to the power of minus x square, and also they are given that this curve is going to pass through a point which is 0, 5 by 2. So based on these conditions we have to find what is the equation of this curve we need to figure out. So here all the options are wrong. So all the options are wrong. This question is basically given in the TS SPDCL in 2018 question. So all the options are wrong. And so now we discuss the exact solution of this question. So let's solve this numerical. So in this question they are given a curve. So for this curve is going to pass through a point 0, 5 by 2 and also at a particular point x, y, the slope on that curve, it is going to have some value which is equal to x into e to the power of minus x square. So this is the expression of the slope at a point of x, y on the curve. So based on these conditions we need to figure out what is the exact equation of this curve we need to figure out. So basically slope is nothing but the rate of change of y coordinate. So therefore dy by dx is equal to x into e to the power of minus x square. So if I take the dx to the RHS, I am going to get dy is equal to x into e to the power of minus x square into dx. So now I am going to apply the integration on the both the sides. So therefore this we are going to get. So let me assume x square is equal to t. So if I do the differentiation with respect to t, I am going to get 2x dx is equal to dt. So therefore now x into dx is equal to dt by 2. So integration of dy is nothing but y is equal to integration of, here in place of x square I am going to substitute t, so e to the power of minus t, and x into dx is dt by 2, so dt by 2. So 2 is a constant value, or 1 by 2 is a constant value, so we can take it outside the integration. So 1 by 2 into integration of e to the power of minus t into dt. So integration of e to the power of minus t is e to the power of minus t by minus 1, because integration of e to the power of ax is equal to e to the power of ax by a. So by this formula we are going to apply the integration. So here finally 1 by 2 into e to the power of minus t by minus 1 plus c, because integration is going to give you basically a general format of equation. So you are going to get a family of curves, so we have to go for the constant c. So if you take the minus upper, we are going to get minus of into e to the power of minus t plus c. So this is the general family of curves, means these are the family of curves at the point of x, y, we are going to get the slope is equal to x into e to the power of minus x square. But out of this all the family of curves, we need only one curve which is exactly passing through this point 0, 5 by 2. So if I want to know what is a particular value or particular equation, then definitely you have to substitute that equation, you have to substitute that initial condition or the point. So if you substitute the point 0, 5 by 2 in this equation, then y is equal to 5 by 2 and x is equal to 0. So e to the power of minus 0 is nothing but e to the power of minus 0 is nothing but e to the power of 0, which is equal to 1. So 1 into minus 1 by 2 is minus half plus c. So if we take the half to the LHS, we are going to get 5 by 2 plus half is equal to c. So c is equal to 3. So if you substitute c is equal to 3, we are going to get y is equal to minus half into e to the power of minus x square plus 3. So this is the exact equation of the curve which is passing through 0, 5 by 2 and also which is having a slope of x into e to the power of minus x square at a value of point x, y on the curve. So we can say these are the things which are necessary. So not even any option has this options. So therefore all the options are, they are not going to match the exact solution. So we can say this is the exact solution. So all the options are wrong. So now we are going to solve the 50th question. See the question here. Suppose f of x comma y is equal to x into mod y is defined on the range of x comma y, which is 1 less than or equal to x less than or equal to 2 and minus 3 less than or equal to y less than or equal to 4. So basically this function is defined on the range of x and y. The ranges of x and y also they have given. So now if modulus of f of x comma y1 minus f of x comma y2 less than or equal to k into mod of y1 minus y2, then what is the value of k? If this is the equation condition, so based on this constraint we have to find what is the value of the k to satisfy this constraint or the condition. So out of these four options, option D, k is equal to 2 is the correct solution of this question. So let's solve this numerical. So in the question they are given that f of x comma y is equal to x into mod y, and this function is defined in the range of x is varying from 1 to 2 and y is varying from minus 3 to 4. So based on these values, so they are given a condition which is modulus of f of x comma y1 minus f of x comma y2 less than or equal to k into mod of y1 minus y2. If this is the condition, then what is the value of k? So what is the value of k we need to figure out. See here f of x comma y1 means in place of y replace y1, so we are going to get x into mod of y1 minus here f of x comma y2, so in place of y just replace y by y2, we are going to get x into mod of y2 and remaining everything is same, which is modulus of less than or equal to k into y1 minus y2 modulus. So here x is a constant, we can say in the both the terms x is a same value, so we are going to take this as a common. So x into mod of y1 minus mod of y2 overall modulus less than or equal to k into modulus of y1 minus y2. So here if you see the value of x is always positive, x is always positive, it is lying from 1 to 2, whereas y it can be positive, it can be negative, but x is always positive. So whenever it's a positive value, we can take it outside the modulus, because we can see a small example, the modulus of 2 into minus 1 is equal to, you can, because 2 is a positive value, we can take it outside the modulus. So 2 into modulus of minus 1, see 2 into minus 1 is minus 2, so minus 2 modulus is 2. Here also 2 into modulus of minus 1 is plus 1, so 2 into 1 is 2, so in both the sides both are equal, means whenever it is a positive value we can take it outside the modulus. So based on the same property, x is a positive value, so we can take it outside the modulus. So you have taken outside the modulus and remaining everything is same as the previous one. So here if a is less than or equal to b, it indicates that b is greater than or equal to a, reverse fashion. If a is less than or equal to b means b is greater than or equal to a. So same thing I have written, if this is a, if this is b, then I have written in a reverse fashion, which is k into modulus of y1 minus y2 greater than or equal to x into modulus of y1 minus modulus of y2. So now we have to know what is the basic equation. Always modulus of y1 minus y2 is always greater than or equal to modulus of mod of y1 minus mod of y2. So you can take any two values and you can substitute in this equation. Let me take y1 is equal to 4 and y2 is equal to minus 3. So by if you substitute in this equation, you can see the equation also. Here 4 minus of minus 3 is plus 3. So 4 plus 3 mod is nothing but 7, greater than or equal to modulus of y1 is 4 minus modulus of y2 means minus 3 modulus is again plus 3. So 4 minus 3 modulus. 4 minus 3 is 1. So modulus of 1 is again 1. So we can see clearly 7 greater than or equal to 1. So we can say that always modulus of y1 minus y2 is always greater than or equal to modulus of mod of y1 minus mod of y2. So therefore we can say that here, so these both are always, this is always greater than or equal to this value. But see, if I want to make it equal, then what I should do? If I want to make this both as equal, then this is a variable. See, suppose let me assume LHS is a fixed value, it is a constant value, and this RHS is a variable. So let me assume this is the range of y, or you can say the range of RHS. See, if I want to make both of them equal, then I can increase this parameter. So when it goes on increases, finally these both will be equal. So therefore here the variable is x if the variable is x, then only this value goes on increases. If the variable x increases to the maximum value, then only both will be equal. So LHS is equal to RHS only when the variable part is maximum. So therefore the variable is x. So both are equal only when here x is x max, means we can say go for the maximum value. So therefore this part will be cancels. So now this part will be cancels. So therefore now what is the value of x? X is equal to x max. The maximum value of the x is 2. So answer is k is equal to 2 is the correct solution of this question. So, or suppose if you forget, let me tell you in another format also. Here these both will be equal if you take both the things are positive. If you take y1 and y2 are positive, then both will be are going to give you same result. See here y1 minus y2 is equal to, this will be condition only when both are positive. So if you take both are positive, like y1 is equal to 4 and y2 is equal to 1, then you can substitute here, you are going to get both the results are same. So you can substitute here 4 minus 1 is 3, 3 modulus is 3 is equal to y1 is 4 and this is 4 minus 1 is again 3. So you can see if both are positive, both are equal only when both are positive. Only then both are equal, but there is a variable. This is equal only when if it's a maximum value. So therefore go for the maximum value. So therefore we can say that k is equal to x max. The x max is equal to the maximum value of the x, which is equal to 2, because we have to make the RHS is equal to LHS, because RHS is a very variable part. See, we only with the increase of x only we can get the value, both are equal. So therefore x max is equal to 2. So k is equal to 2 is the correct solution of this question. So now we are going to solve the 59th question. See the question here. What is the Laplace transform of e to the power of theta t into sine of omega t? So we have to find what is the Laplace transform of e to the power of theta t into sine omega t. So out of the four options, option B is the correct solution of this question. So let's solve this numerical. See, for the function f of t, if the Laplace transform is f of s, then for e to the power of minus a2 into f of t, the Laplace transform is f of s plus a, means replace s by s plus a. So by using this property here, sine omega t, for sine omega t, the Laplace transform which is omega by s square plus omega square. But in the question they are asking what is the Laplace transform of the e to the power of theta t into sine omega t. So by using the basic principle, which is here sine omega t Laplace transform is omega by s square plus omega square. But now we have to replace s by s plus a. So replace s by s plus a. But if you compare both the things, here exponential part is minus a and here theta. So minus a is equal to theta. So therefore a is equal to minus theta. So wherever a is there, just replace minus theta. So s plus a means s minus theta. So wherever s is there, just replace by s minus theta. So omega by s minus theta whole square plus omega square. So therefore the Laplace transform of e to the power of theta t into sine omega t, which is omega by s minus theta whole square plus omega square. So this is the correct solution of this question. So now we are going to solve the last question of this lecture. See the question here. If a, b and c are the vectors where a is equal to 1 ux plus 2 uy plus 3 uz and b is equal to 1 ux plus 1 uy plus 1 uz and c is equal to 3 ux plus 2 ui plus 1 uz, then a cross b dot c we need to figure out. So basically here ux, uy, uz are called as the unit vectors. We can write ax, ay, az also. So now we have to find what is the a cross b dot product of c we need to figure out. So out of these four options, option C 0 is the correct solution of this question. So let's solve this numerical. So basically I have replaced ux, uy, uz by ax, ay and az. So here a is equal to 1 ax cap plus 2 ay cap plus 3 az cap, and b is equal to 1 ax cap plus 1 ay cap plus 1 az cap, and c is equal to 3 ax cap plus 2 ay cap plus 1 az cap. So based on these three vectors, we have to find what is the value of a bar cross b bar dot product of c bar. Means this we need to figure out. See, always the dot product is a commutative property, which is a bar dot b bar is equal to b bar dot a bar, because we can say that the dot product is a commutative property. So therefore we can replace this thing, interchange these ones. So I did the interchange, which is c bar dot of a bar cross b bar. So if you want to know what is this value, then we have to go for the determinant of this matrix. The first vector is c, so take all the components of the c vector, 3 2 1. 3 2 are in the first row. Similarly the second vector is a bar, so take all the components of the vector a in the second row, 1 2 3 1 2 3. The next vector is b bar, take all the components of vector b in the third row, 1 1 1. So 1 1 1. So now we have to find what is the determinant of this matrix, which is 3 into 2 minus 3 minus 2 into plus 1 minus 3 plus 1 into 1 minus 2. So by using the basic determinant matrix. So if you solve this one, we are going to get minus 3 plus 4 minus 1. So minus 3 and minus 1 is minus 4, plus 4 is again, they are going to get cancels, and finally you are going to get the result as 0. So we can say simply the A bar cross B bar dot C bar is equal to 0. It indicates that these three vectors are going to lie in the same plane. These three vectors are going to lie in the same plane. So therefore the overall volume generated by them is equal to 0. So you can go for any other format, which is B bar dot A bar cross C bar, or you can say here B bar dot A bar cross C bar. You go for any other fashion, still you are going to get the same result as 0, because all these three vectors are going to lie in the same plane. So overall volume generated by these three vectors, because this is going to give you the amount of volume generated with the help of these three vectors, it is equal to 0. So this is the correct solution of this question. So by this lecture we have successfully completed the 60 questions in a very detailed manner. And if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notice comes on mobile. If any improvements in our lectures, then please do comment in the comment section. We will definitely give all those improvements in the coming lectures. Please do watch all our videos in the YouTube itself, so that our channel will grow and it will reach to the more number of students. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.